Hello, and thank you for watching the operating systems term project for Jesus Ravelo of the Summer 2 2024 semester. So, in the term project, my topic that I have chosen, or the operating system that I have chosen to research, is QNX. And so I'll just dive right in. I'm going to start with a introduction and go through each of the points that I have in my work document that have been attached to the D2L submission. So to start, I'm going to talk a little bit about QNX, why I chose QNX, and how it's different from other operating systems. And so MBOS represents a microkernel-based operating system, which is a type of OS that uses a minimalistic kernel design. Its main focus is separating core functions from the higher level services and applications. And so the idea is it's going to enhance the system's reliability, modularity, and security by reducing the kernel's responsibilities. And so just kind of to explain how that's different from our traditional operating systems, in a article that Sealwell wrote, they wrote, in a monolithic kernel, all operating system services, memory management, process management, file management, and I/O management run along the main kernel thread and live in the same memory area. Where in a microkernel system, we're able to isolate each application, driver protocol stack, and file system into its own space outside of the kernel. Okay, and so this is something that was developed by Quantum Software Systems in the early 1980s. But the main reason why I selected QNX in this research is because of how much we actually use it in our day-to-day without even knowing. Before doing this research, I wasn't, aware of what runs my Volkswagen's CarPlay when I plug it in, or the infotainment system, right? And so knowing that QNX is an operating system that is used in not just my vehicle, a lot of the vehicles that I see day to day, just allowing the users, myself included, to go through and access all the services that you would use in your car, like Bluetooth, or seeing the status of the tires, or being able to and creating different profiles for the settings that you have. And so it's interesting. It's something that I never would have thought about, and now knowing that QNX is used for a lot of that, it's industry leading. It's mind-boggling, and so it's something that influenced me in choosing this operating system as my topic. And so I won't read through any of these PowerPoint slides word for word, but you will get the slide and the page from the Word document. And so the next point that I have is the historical perspective of QNX. And so it's important to understand the history of QNX because it's matured a lot since the 80s. And so in the 80s, we had QNX 1.0, which focused on just an operating system that is focusing on real-time capabilities, doing something now on the spot. And in 1990, they released QNX 4, which brought enhanced networking features and POSIX compliance. POSIX compliance here is really important, and it's something that we're going to talk a lot later about in this document. So I'll just kind of go over that, but I just want to mention POSIX compliance. And in 2001, the introduction of QNX Neutrino real-time operating system modernized the operating system with improved modularity and scalability. And in 2010, it was acquisitioned by BlackBerry, which really is what led it into its integration into the automotive and the mobile industries because of the standards and different things that it had to adhere to and comply with for that. And so that just made it so much more usable, manageable by different companies in different industries. And so an example of that would be Boston Dynamics. They're an industry leading in robotics, And in 2015 they announced that all of the robots are running off of QNX. And so this is incredible because you take a look at Boston Dynamics and everything that it's done, and they're building some of the most stable human-like robots that we've seen. And I think it's important that we understand, what is running that, and behind the scenes, it's QNX. And so I think that's really interesting. Another example of this is in the aerospace industry. SpaceX is using QNX to as a part of their Falcon rockets, and so because of its ability for fault tolerance and reliability, we're able to use it in systems where there is high pressure, right? We need you to perform. We need things to get done the way we expect them to be done. Let's use QNX. And so I think that's something that is incredible. And another example would be, like I mentioned earlier, the automotive industry, where as of 2024, there's over 235 million vehicles with BlackBerry QNX software installed for its infotainment system. Goals and purposes of QNX. The goals and purposes of QNX are mainly revolving around real-time performance, reliability and robustness, and modularity and scalability. And so we really just want to make sure that we're getting things done in a specific time frame. We want to maintain stability and continue operations under different situations. And so if there's a fault or high loads, we want to have different ways to support fault tolerance, redundancy, and error handling. And so as far as modularity and scalability goes, when we compare it to different operating systems, it's what makes QNX so powerful, because of it leveraging that microkernel architecture and having core functions be separated from higher level services. So the main goals and purposes of QNX is to maintain real-time performance, reliability, robustness, and modularity and scalability. Standards and platforms that are governing QNX involve POSIX compliance. That's something that we talked about earlier, but it provides essentially compatible with other popular operating systems that are similar to Unix, and so it aims to standardize APA standards and keep a consistent structure for different operating systems and different devices that we can interact with essentially. And so by nature, QNX has to adhere to a lot of different standards, and so there's a few listed here in the document, and I won't go into each one's detail, but we mentioned earlier SpaceX working with QNX, and so they have to adhere by DO 178C. In the medical industry, we have a couple of different standards that QNX has to comply with in order to use those kinds of devices, and also for the automotive industry, right, that we've seen. And so it has to remain flexible for all of the different range of applications that it can be applied to. And so because of that, it makes QNX a really reliable and versatile operating system. As far as the design of QNX, it emphasizes that microkernel based operating system, and it aims to maximize those three things that we mentioned earlier: real-time performance, modularity, and reliability. And so it's doing that using inter-process communication, which is essentially just message passing between different processes. And it makes sure that there's each interaction between different parts of the system are quick and predictable. That way it doesn't have to do a lot of solving. And so that's kind of at the core of the newest implementation of QNX, Neutrino real-time operating system. It's supposed to use a lot of scheduling and context switching, and so it's going to make it really useful for a lot of different industries. The subcomponents of QNX, I guess there's a lot of different ways that you can break it down, but the couple that I had seen was the microkernel, the Neutrino RTOS, real-time operating system, its different device drivers, file systems, and networking components. And so here in this screenshot of a article that I found that has this image, it gives a brief breakdown of the Neutrino real-time operating system. So you'd have like your screen, so given an infotainment system, anomaly detection, encrypted file system, its core operating system, which has that microkernel and other services within it, and then any other hardware support working outside of that. And so because of those being separated, it comes with that microkernel architecture. Next is the integration and the functionality. So as I mentioned earlier, QNX has a lot of different standards that it's adhering by. Excuse me. And like we mentioned earlier in this document, the inter-process communication in QNX, it's really efficient, and it enables fast communication, right, between these different processes and components. And so it's going to ensure that things are allocated, in real-time constraints are met, as you would need in a operating system that is, functioning real-time. So by supporting processes such as, path namespace mapping, we're able to have well-defined interface to resource managers, and to provide specific sets of libraries for different functions. So everything that I could find as far as the integration and functionality on QNX was held really high because of its modular design, and it essentially just allows for easy customization and extension into different systems, which makes it suitable for a lot of different industries and applications. And so because of the way that you can have something in place and pull things in and out without having to affect the next process, it really enhances how the system is maintained and how it's flexible. So that's something that's really important, and a big advantage with QNX. The complexity of QNX is pretty high, and with that comes a high cost. Not a lot of people are familiar with QNX, and because of that, of course, that's going to come with a high cost whenever you are trying to find developers for a specific project or for a specific task, because it's not just let me find somebody who knows how to get this done. There's a lot you have to do. You have to test it, you have to QA it, you have to make sure that it's being built up properly, and so that alone costs a lot of money. And not only that, things like licensing. So licensing for commercial uses is going to have a lot of fees, right? Because you're using it for large scale projects, and as a company, it's going to run you a lot of money. So like say you're Tesla and you're running a lot of autonomous vehicles, and that's going to have a lot of significant licensing fees for each car that's running that autonomous system. So because it's not just you build it once and you can apply it, right? No, each one of those devices has to have that installed, or has to have a license for it. And so that cost alone is going to be really high. And so just integration even is going to have a lot of custom development, like we talked about earlier. It's not just building the device one time. You have to support it, you have to maintain it, you have to test it, and so that's going to drive high cost. And so there's a couple of different pros and cons of QNX. And here we'll go through a couple of those. The advantages is its real-time performance, reliability and stability, modular design and scalability, its security, and its wide industry acceptance because it can be used across a lot of different industries. Its disadvantages or its cons, it's going to be how complex it is to implement, the licensing costs, like we talked about just now, the development and maintenance costs, because it's not just building the system, the application that you're trying. You have to maintain it, you have to test it, and integration challenges because of it being, pretty specific, and so you have to have a specific set of people with a specific skill set that can integrate QNX successfully, and so that is not only hard, it's expensive, and so those are a couple of disadvantages. But nevertheless, there's a lot of companies that are involved with QNX. Our biggest example is BlackBerry because they are its current developer and maintainer. But among these companies, there's a lot of automotive infotainment like Audi and BMW, and I think, like I mentioned, that's insane. It's crazy to me that these big companies are using an operating system I've never heard about. But here in this graph, I talked a little bit, or it talks a little bit about the different industries that are using, and that are using QNX and its top contributors. And so here we'll see that IT and services are at 18%, and customers computer software is at 10%, and automotive is at 8%. So a pretty nice breakdown of the top industries that are using QNX. And so as far as the future trends, I can see QNX being used for a lot of different cloud-enabled technologies. So during CES 23, QNX announced that the QNX Accelerator Initiative, which is going to introduce a cloud-enabled version of Neutrino RTOS for the AWS marketplace. And so that's something that's going to be big within that cloud community. And so being able to integrate QNX into these future technologies is going to be key to its success. And also the automotive industry is only going to keep growing. They're only going to be more and more involved with these technologies, and so it's going to really drive more growth for QNX. And so just to conclude, QNX is going to be a robust real-time operating system that is known for its microkernel architecture that enhances reliability, modularity, and real-time performance. It originated in the 1980s and is now developed and maintained by BlackBerry. It is applied across a lot of different industries like the automotive, industrial, medical, and telecommunications industries. And some of the biggest benefits of QNX include being able to use it across a lot of different applications because of its standardization and acceptance in different industries because of whatever it might be, POSIX, compliance, or ISL 26262 for the medical industry. But with all of that, QNX is very, very specific. It can be very costly, but for those reasons, businesses will continue to use QNX. It will continue to invest and think of different ways to leverage this technology. And so that's my presentation for the QNX term operating system. I hope it has everything that we needed to cover, and I really appreciate your time. Thank you.